Welcome back to another episode of the igus Classroom series. My name is Jan Hennecke and I'm the product manager of low-cost automation here at igus. Today we want to talk about robot arms in industrial automation. I want to talk to you about some of the advantages and disadvantages, some of the use cases, and some of the history that igus has with robot arms. Some of the advantages of robot arms are that they can do very complex motions due to the fact that they have many joints. Just like your arm, you can rotate it in any kind of way. This is not only great for complex motions, but this allows typically one robot arm to be able to fill many different applications. It's a very flexible robot that can be used on different workstations for different purposes and can be switched over time. Some disadvantages are that the robot typically moves slower than a highly specialized robot and can't achieve the high cycle times. And typically, robot arms have lower payloads than other automation systems. Next, I want to talk about some of the use cases. Robot arms are great for pick-and-place applications, typically complex motions. They're also great for inspections, as you can see here. Sometimes you also use robot arms in testing and assembly tasks. Now, let's look at the history of igus and robot arms. igus started in 2009 with the draw-wire robot. This was a patented technology with more individual motors that would pull on strings to bring the robot into the specific orientation. We then graduated into a robot build kit, a modular kit where you could use individual joints and extend arms and basically build your own perfect robot for your application. In 2014, we came out with our robolink family. It's based on our worm gear drive technology and allows for very precise locations and good payload capacity. And lastly, very exciting, in 2020 we released our first collaborative robot, the Rebel. Let's dive deeper into the robolink family and the Rebel family to see what kind of options we have there. The robolink family is based on the robolink joint. We use these in every joint of the robolink. It comes in the standard 5 degrees of freedom version, but also as a splashdown version for washdown environments. Typically, the standard version of these robots have 3 kilograms of payload and 790 millimeters of reach. They're also considered an industrial robot and can be controlled with our igus robot control software. Next, the Rebel family, based on our strain wave gear technology. We have 2 different sizes that come standard for the strain wave gear. 80 millimeter diameter, the small version, and 105 millimeter, the large version. You can take any of these gears and build your custom robot, but we decided to do it for you and build some standard off-the-shelf robots that are called the Rebel. The Rebel is our first 6-axis collaborative robot arm. It has 2 kilograms of payload and 650 millimeters of reach. The plug-and-play version, the controller is in the base, but you can also have it as an open source version without the controller and build your own custom controller for it. As an alternative and even more affordable solution, we have the 4-axis collaborative robot arm, where we took out the small 2 joints in the tip of the robot. And lastly, the Rebel kit, our first robot for the single purpose of education. A small compact robot that is very easy to program and use for any kind of learning setup. Next, I want to show you how to program our robot arms. Let's go up to our Robotics Lab and I'll show you some of the tips and tricks on how to program our robots in our igus robot control software. Welcome to our customer test area. Here we have all kinds of igus robots, but also robotics add-ons like grippers, conveyors and extrusions displayed from igus, but also from our RBTX partners. With us here are 2 Rebels, one Rebel in the lifetime test and also a Rebel on the 7th axis. Also with us is Dylan, our automation engineer and our automation expert, and he will guide you through a sample program of a standard pick-and-place applications that we see a lot in the industry. So without further ado, I'll hand it off to Dylan to show you through the IRC, the igus robot control. Hope you enjoy.
So here we have the igus robot control. This is the digital interface that you'd see. Information on how to download this will be found in the description. It's very simple to use. You have joint controls down here. You can also freely select a joint and allow motion there as well. You can select between the type of motion, whether you're moving it based off of degrees per second or if you'd like to move it in a Cartesian coordinate system. And that's what we'll be doing today with pushing those buttons that you see there. So you have simple Y motion in here. You can drop in the Z as needed. And so it's very simple to program these points. And so what we're going to do is just open the program editor here, and we'll start a new program. We can actually orient the screen so we can see both the robot on there and we can also see the program. First thing, we'll enable this as our first movement. All you have to do is just click J or L on the keyboard. That will implement either a linear or a joint movement. Very simple. It records the current position that it's in. And then what you can do from there is simply bring it over, drop it down to its desired positioning. You might have to just tweak it a little bit. And I'm going to set one more point there, and then I'm going to have it drop straight down to push the button. So now that it's made contact, I can add one more position, and we're just going to bring it right back up again. And record that point there. And so now what we can do is I'm just going to change it to joint movement because I'm just going to be moving the base, and I'm going to give it a full rotation to the other side here, roughly about there. So I will record that as a joint movement rather than linear in this case because I was just moving one axis there. I'll switch it back to base movement where I'm back in Cartesian coordinates, and I will drop down on the Z axis. And that will get me right to the second button there. And I can just click L again, bring it back up in the Z, and I'll record this position. And so what we can do here is just hit save. We'll call it test program, enter. Looks like I already made one, so we'll do one more. And then all you have to do is hit run. And so you can see in the software, it is mimicking what it's doing in real time, and you get an accurate representation of the system. You see it just went down and hit the first green button there, and now it's making its way over using that joint position, and it'll drop down and hit the red one as well. Very simple programming. This is a definition of a PIC that we offer with our systems, and this program can be found preloaded into the systems as well for just proof of concept, simple testing. Right now it is set on replay mode, so it will just keep going until you initiate a stop. You can also change it over to single motions as well, or single cycles in the program. That would allow for it to stop once it hits this last movement here. So you see the program stopped. You can also change it to step mode. This would allow you to go movement by movement, and it'll stop at each location. So let's say you're programming the system and you need to slightly modify the location. You do have this little white dot in the program editor that does track what movement it's on. If you need to adjust the movement at all, you can stop the program, readjust as needed, right click and just hit touch up, and it'll reinitiate the coordinates. Hit save again, and you can actually start it right from that movement there. So you hit start here, and it'll go through the program again. So that was just a quick demonstration on how you can use the IRC software and make a quick program in just under a few minutes there. If you need any help on any of the information, you can find this little question mark in the right-hand corner, and you will have troubleshooting information that takes you to our Wikipedia page that would allow you to access a whole bunch of information on there. For troubleshooting information and software updates, you can click the question mark in the bottom right-hand corner, and it will take you directly to our Wikipedia page, which has a plethora of information. Thanks for watching, and I hope you guys learned something today.
Thank you for tuning in to another episode of the igus Classroom series with Dylan and myself. I hope you learned something today. If you have any questions, don't hesitate to reach out to Dylan or myself. You can also contact us through igus.com or rbtx.com. Thank you for tuning in, and I hope to see you next time.